Okay, you should have this blank handout in front of you. If not, go ahead and get it, or you can copy it down by hand if you don't have access to a printer. But we are doing some fill in the blank for the first time in a long time. This is on exponential functions notes. We are only focusing today on growth. The next set of notes will focus on decay. But when we talk about exponential growth, these are things that grow quickly over time. They're not at a steady rate. Everything we've looked at so far has been linear. So it looked like this, right? Growth over time. That is not the case when it comes to exponential growth, right? So forget about that for a minute. I'm not going to do those right now. Exponential growth grows over time, just like I showed you in the last notes about intro to exponential functions. It is represented by a specific equation. So when you see this equation, you'll know this is growth over time. You'll know it has to do with exponential functions. The A is the initial value or your starting point. T is the time. It's over here. Y is your final amount. Like that's the final value you end up with. And R is your rate of change over time. So where you'll see this a lot is with things like compound interest in a bank account. But we're going to start with talking about a few other examples, and we will work our way up to that. All right. So if we look at this first one, example one, and sorry, it's a little bit small. Let me zoom in a little bit. The number of users in millions that belong to a social networking site can be represented by that equation, where T is the number of years after 2013. So I would actually mark T number of years so that you remember, right? We're not looking at any other time in here. They tell you what the time is. They did tell you it's years after 2013, so I know 2013 is my starting point, and they want me to interpret the parameters of the equation. Well, when I think about what I would be looking at, right, they've given me the equation here. My A value, which, right, is this, the one in this position right here, my A value is 1.5. And that's the number of users in millions in 2013, because they tell me this equation is everything after 2013. So I know my starting value was, that was the number in 2013. My R, or my rate, is right here. And you'll notice it's 1.4. So they added 1, so really the rate is 0.4. But when you look at 0.4, that's 40%. That's a huge growth rate. That's typical, I guess, when you have a social media site taking off. It would not be typical in the amount of interest or anything where someone is paying you. It would be significantly lower than that. So just remember 0.4 is 40%, and that is the rate of increase over time. Let's look at another example. So in this next one, the prize for a radio station contest begins with a $100 gift card. Once a day, a name is announced. The person has 15 minutes to call, or the prize increases by 2.5% for the next day. So they want an equation to represent the amount of the gift card in dollars after T days with no winner. Well, we know our A, our starting point, is that $100 gift card. Our rate is 2.5. This is 2.5. This is not 25. Make my point a little more obvious. 2.5% is the growth over time. That's each day. And when written as a decimal, it looks like this, because it always has to be written as a decimal. So my equation would be y equals 100. I just plugged that in for my A value that I had up above. Let's see if I can get them both on the same screen. So this is 100. Got it. 1 plus my rate, 1 plus 0.025. And then that's to the power of T, which is the time in days, because it tells you once a day that's what's going to happen. So then they ask, how much will it be worth if no one wins after 10 days? Feel free to go ahead and solve this one on your own if you'd like to. It may be difficult to do exponents on your phone, but if you're in the classroom, you can try there. And if you want to try it on your own, pause the video now, because I'm going to keep going. All right, so if they want to know how much the gift card will be worth if no one wins after 10 days, I would say y equals 100 times 1.025, because that's 1 plus my rate of 0.025, 1.025, to the power of 10, because it's asking about 10 days. Now, when you see time, you might be looking at things like 15 minutes up here. That's not part of the equation, right? We're looking at time that it increases or that it changes. What is their next benchmark point for when the amount is going to change? That's where you see next day. So sometimes STAR questions will throw both of these things in there because they're both related to time. They can trip you up. If you put this into your calculator, especially the TI Inspire, you should get $128.01. It's actually like 0.008, but it's money, so we round up to 1 cent. We do not need to do the bottom example. I just want to remind you from the previous notes that growth looks like this. The asymptote is not always 0, but it will grow over time as you move from right to left on the graph. Decay would be going down over time. Think of growth and positive slope are kind of the same. They're both going uphill. Puff, puff, positive, and nice negative is your negative slope / also the direction that decay would be going to decrease over time.